Hello, everyone. My name is Jesus Cantu, and today I'll be showcasing my project, Conservation Made Easy, fine-tuning Gemma for an invasive plant QA chatbot. Currently, I hold a Bachelor's of Arts in Sociology, as well as a Master's of Science in Software Engineering. I work at the TMW Center for Early Learning and Public Health at the University of Chicago, where I build machine learning algorithms for different tasks, particularly audio classification. Which we use to sort of analyze child and caregiver conversations and to develop metrics to enhance child development over time. My future goals is to advance as an AI ML engineer and to deepen my expertise in text, audio, and image processing. The problem definition is that I was interested in creating a chatbot that could tell people if plants were invasive or not. Invasive plants pose significant ecological threats here in the United States. They outcompete native flora, alter ecosystems, reduce biodiversity, and overall cost millions in management and control efforts. Accurate identification and understanding of plant species is essential for environmental management. And there's a need for an accessible tool to provide plant information to conservationists, land managers, and the public. My objective was to develop a chatbot-style model using the Gemma framework to deliver accurate information about plants, invasive or native. Users will be able to use a plant's common name or scientific name to receive information about the plant, including its ecological threat, growth characteristics, and suggestions for management. The data collection was extensive. I collected data for over 15K plant species reported to be invasive in natural areas across the United States. I scraped data from different plant databases, including the United States Department of Agriculture and invasive.org. Some of the key features included the common name, scientific name, the plant symbol, US nativity, the growth habit, ecological threat, and invasive or noxious status. The data was transformed into QA format to train the Gemma model. And I tried to create 10 diverse templates for each feature to handle different ways of curing that information. Example question categories include what is the USDA plant symbol for a specific common name or scientific name. Nativity, is this plant native to the United States? And describe its appearance. So what does the plant look like? My model architecture included the Gemma-2B Instruct, and I used Keras and LoRA for fine-tuning. I thought that the Gemma-2B would be lightweight, and with the 2 billion parameters, have enough information to answer diverse queries about plant species. Some inference before fine-tuning. Some examples are this. As you can see, I asked what plants are invasive in the United States, and it responded with sort of like repeating the same information over and over again, specifically about the plant silver wattle. So without any fine-tuning, the information is not very accurate or detailed. Inference after fine-tuning tells a different story. So we get more information about plants. One of the questions is how does this plant particularly grow? And it gives me that information, which is correct. Another question that I asked is pear flower known to invade natural areas in the United States, and that's what we're looking for. Yes, it tells me that the plant has been reported to be invasive. And again, this information is correct. And another question that you can ask is, what are some defining features of the plant? And it'll give you detailed information about its appearance and growth characteristics. Some of my future work includes creating a multimodal data set so that I can fine-tune a polygemma model to enhance its understanding of visual and textual plant information. I want users to be able to present a picture and get information about whether a plant is invasive or not, and again, all the other metadata about the plant's growth over time. And I want to deploy the fine-tuned model using Gradio to create a user-friendly interface for real-time plant identification. Some of the lessons I learned was how to create data for LLM training. I learned a lot of different information about Gemma model variants. including what computational resources are needed to fine-tune those models. I also learned how to use GCP and Google Colab for fine-tuning and evaluation. Here are my project links. You can access the model on Kaggle. You can visit the repo to kind of see all the different Jupyter notebooks and the data, and to get the data set needed to fine-tune it. And I hope you get inspired and learn how to fine-tune your own Gemma model on Kaggle using my example. Thank you very much.